Northern lights, or polar aurora, are natural glows seen in the sky in the polar regions, resulting from the interaction of the Earth's magnetic field and charged particles from the Sun. In northern latitudes, this effect is called the aurora borealis or northern lights. The formation of the aurora australis, southern aurora, at southern latitudes has similar characteristics. However, it can be seen from higher latitudes in Antarctica, South America and Australia. If you want to support my channel, you can like the video and subscribe to my channel below. Don't forget to turn on notifications to be notified of upcoming videos. These radiations, usually observed at night, occur predominantly in the ionosphere. This phenomenon commonly appears between 60 and 72 degrees north and south latitudes, which falls within the Arctic and Antarctic polar circles. The likelihood of the aurora borealis appearing increases as you get closer to the North Magnetic Pole. Auroras formed near the magnetic pole are exactly 90 degrees, but from afar they illuminate the northern horizon with a greenish glow, sometimes a pale red as if the sun were rising from an unusual direction. The aurora borealis often occurs at the solstices. Auroras can be observed from all over the Earth and on other planets as well. The closer they are to the poles, the more visible they are due to the longer duration of darkness and magnetic field. The word aurora comes from the name of the Roman goddess of the dawn. Boreas is the Greek name given to the north wind by Pierre Gassendi in 1621. The Cree people called this interesting event the Dance of the Spirits. In the Middle Ages in Europe, it was believed that auroras were signs from God. Auroras are in the upper atmosphere, from an altitude of 80 kilometers, 50 miles, above, where ionized nitrogen atoms gain electrons, and the excited, high-energy level, oxygen and nitrogen atoms return to the ground energy level, resulting in photon emission. They were ionized by the collision of solar wind particles and accelerating along Earth's magnetic field lines. The high-energy level decreases as a result of the emission of a photon of light or its collision with another atom or molecule, green or brownish red, depending on the quantity of energy swallowed. Nitrogen emissions blue or red. Blue, if the atom regains electrons after being ionized. Red if returning from a high energy level to a basic level. It is not uncommon for oxygen to return to the baseline level. It takes 3/4 of a second to emit green light and up to 2 minutes to emit red light. Collisions with another atom or molecule will absorb its high energy and inhibit emission. The top of the atmosphere is both high in oxygen, and such collisions are so rare that it takes time for the oxygen to emit red. As you go further and further down through the atmosphere, collisions become more frequent so that there is no time for red emission to occur, and eventually green light emission is also blocked. Here is why the colors change depending on the height. At higher altitudes, oxygen red dominates, then oxygen green, and finally nitrogen blue, red when collisions prevent the oxygen from emitting anything. Green is the most common of all auroras, followed by pink, mixture of light green and red, traces of pure red, yellow, mixture of red and green, and finally pure blue.